Hello everyone. My name is Aarifa from AGS channel, only destination for learning. So this is the fourth video on the chapter matter in our surroundings. The remaining or the other three videos are available in my channel, and my channel name is AGS, only destination for learning. This is the fourth video, and the topic of this video is, can matter change its state? See, in previous videos I have explained you that matter exists in three different states, isn't it? Solid, liquid and gaseous states. In today's video we shall see how this matter changes its state from one state to the other. For that we shall experiment with the change in temperature. How the change in temperature helps to change the state of matter. So, effect of change of temperature. With this topic, we shall look at the change of states of matter. See, you know that water, universal solvent, exists in three different states, isn't it? Solid, liquid and gaseous. And do you know why water is called as a universal solvent? See, the reason is that water has the ability to dissolve almost all kinds of particles in it. 99% of different types of matter can be dissolved in water. That's why it has been given a name called universal solvent. So this water exists in three different states: solid, liquid and gaseous, isn't it? And it has three different forms. In solid, it exists in the form of ice. In liquid, it exists in the form of water. In gaseous form, it exists in the form of vapor. With the example of this water itself, we shall examine how we can change the states of matter. First of all, if you take ice in a beaker and try to change its state, we have to apply the temperature. Now we have taken ice in one beaker and we are applying heat energy. So now the ice which is present in this beaker, it starts to melt, isn't it? At the temperature called 273.16 Kelvin, the ice which is in solid form, it turns to liquid. That is nothing but the water. The state of the solid state of this water ice is going to turn to liquid at the temperature called 273.16 Kelvin. And here Kelvin is the SI unit of the temperature. Okay, Kelvin is the standard unit which we use to measure the temperature, and if you want to convert the degree Celsius to the Kelvin, you have to add 273 degree. Here we take 0 degree Celsius is equal to 273 Kelvin approximately, by rounding off this decimal 0.16. So if you want to change degree Celsius into the Kelvin, you have to add 273 to it. If you want to change the Kelvin scale to Celsius, you have to subtract 273 from the given temperature. Okay. Now when the temperature scale it shows 273.16 Kelvin, ice starts to melt. The heat energy which we are supplying here, this heat energy is utilized by the particles of ice in order to overcome the forces of attraction between them. In order to break the bonds, the heat energy which we are supplying is utilized by the ice. And if you observe that the temperature of the entire system, it doesn't change until the complete ice it turns up to the liquid. Until the complete ice is going to melt into a water, the temperature doesn't change, though you are supplying the system with the heat energy continuously. So where does this heat energy supplied goes. This heat energy which we are supplying is utilized by the particles of ice in order to free up themselves and change their state to the liquid. And this point where the melting of ice into the water is called as the melting point of water. Okay, melting point of water is 273.16 Kelvin. This is a melting point, and the change of state of solid into the liquid, this is called as fusion. Okay. The change of solid ice into the liquid water is called as fusion. And as we have seen, though we are supplying the heat, the temperature of the entire system doesn't rise. And the heat, whatever we are supplying, that is hidden. So this hidden heat is called as a latent heat of fusion. Here the word latent is nothing but hidden. Since though we are supplying heat energy, the temperature is not rising, it is termed as latent heat of fusion. And this can be defined as the amount of heat required to convert 1 kg of solid. To convert 1 kg of solid into the liquid is called as latent heat of fusion. This is how the temperature helps us to change the state of solid into the liquid. Similarly, liquid also can be converted into gaseous state by changing the same temperature. When we take water in its liquid form and if we supply the heat energy continuously, water at some point it starts to boil, and that point of temperature is 100 degrees Celsius, and when the water starts to boil, that point is called as the boiling point. Usually water boils at 100 degrees Celsius, and if we need this in its SI unit, you have to add 273 to it. 100 plus 273, it is 373 Kelvin. At 100 degrees Celsius, water starts to boil, and here, in order to reach its boiling point, water needs more and more energy, thus more heat should be supplied. And here the heat energy which we are supplying is used to break the bonds, and it is used to convert itself into the vapors. Until the water converts into its vapor, it needs more and more heat energy when compared to the melting point of ice to the water. So here 100 degrees Celsius is the boiling point of water, and if you want it in a Kelvin scale, it is 373 Kelvin. So here it is called as latent heat of vaporization. Since the heat energy supplied is used to convert itself into the vapors, it is called as latent heat of vaporization. So conversion of water into the gaseous state is vaporization, and the heat supplied is not going to be shown on the temperature scale. That's why it is called as latent heat of vaporization. Thus, with the change of temperature, we can convert one state of matter into the other. There is even one more case where you need not to go to the liquid state. Directly from solid to gaseous, you can change the states of matter. What is that called as? Let us have a look. See, when you take certain substances like ammonium chloride, and if you take this ammonium chloride and supply the heat energy, this ammonium chloride being a solid, without changing its state into a liquid, it vaporizes. This system of conversion of solid to gaseous state directly without changing itself into the liquid is called as sublimation. So sublimation can be defined as the process of change of a solid state into a gaseous state is called as a sublimation. And in your daily life we can see such examples like camphor, which is used for aarti and all. They use it in just whitish color balls like structure. These are used for the sake of aarti and all. When you light up these camphors and all, what is going to happen? They vaporize. They do not change themselves into a liquid state. So this conversion of solid to gaseous state directly without changing themselves into a liquid is called as a sublimation, and ammonium chloride is one such example. Okay, ammonium chloride, camphor are the best examples for such cases. And this is one about the effect of change of temperature in order to change the states of matter. Next one is effect of change of pressure. Not only the temperature, even pressure helps us to change the states of matter. How pressure is going to change the states of matter? Let us have a look. See, other than the temperature, even pressure helps us to change the state of matter. See, you might have heard about the carbon dioxide, which is one of the major essential for all the plants in order to exist. So such carbon dioxide, it can be changed into its gaseous state by applying a greater pressure upon it. Say carbon dioxide, it is stored under very high pressure, and the solid carbon dioxide can be changed into its gaseous state by applying high pressure on it. By reducing its pressure, the solid carbon dioxide can be stored in the form of gaseous states, and this carbon dioxide is very much helpful, and it helps in distinguishing this fire accidents and all. See, whenever you visit certain hospitals or any organizations, institutions, you can find a red color cylinder which is kept here and there. What is that? Is nothing but this carbon dioxide. This helps us in order to extinguish the fire accidents, in order to save ourselves during the major fire accidents. So this carbon dioxide, since it is stored under high pressure, this is also called as a dry ice. Solid carbon dioxide has a title called dry ice, and it can be stored in cylinders by reducing its pressure, and without converting itself into the liquid, we can change it directly from solid to gaseous states. So not only the temperature, even pressure helps us to, or altering the pressure of a substance helps us to change the state of matter. So the temperature and the pressure factors determine the state of matter, which are most essential. And now if you move on to one more topic called evaporation. See, evaporation is nothing but changing the state of matter without reaching its boiling or melting point. We can change the state of matter. How evaporation helps us to change the state of matter? Let us see now. So we can find many examples of evaporation in our daily life. See, when we wash our clothes, what we often do in order to dry these clothes, we often put them in a hot summer. After a few minutes, after a couple of minutes, what is going to happen? We can find the wet content is almost lost, and we can get our dry cloths. What is happening here? The liquid content which was there in a wet cloths, that has been vaporized now. Not only in that case, even if you keep anything, whether a solid, liquid or gaseous substances, you can find evaporation because particles in a matter are continuously moving. They have a kinetic energy even at the state of rest. If you keep a beaker of water undisturbed for a couple of minutes, what is going to happen? The water, it vaporizes, isn't it? You cannot see it on a large scale, but even at a negligible scale, you can see evaporation. So now this evaporation can be defined as the phenomenon of changing of liquid into vapors without reaching its boiling point. See, without reaching the boiling point of any substance, you can change liquid into the gaseous states. Without reaching its boiling point, we can convert the state of liquid into the gaseous state, and this is called as evaporation. And there are many factors which affect evaporation. What are they? The first factor which affects the rate of evaporation is increase in surface area. See, almost for a greater evaporation, the surface area should be broad. See, take the example of clothes itself. If you dry up the clothes in a hot summer, you will not just keep them. You will increase the surface area of the clothes by extending them or by opening them completely. You will put your clothes for drying up. So, increase in surface area enables a faster evaporation when compared to the less surface area. So, this is the first factor which is most essential for the rate of evaporation. The second one is increase in temperature. So, temperature also should be more. Increase in temperature. This is a second factor which helps for the higher rate of evaporation. If temperature is more, you can get evaporation, you can get better results of evaporation. During a rainy day, you cannot expect higher evaporation. Okay, so temperature should be more for the sake of higher evaporation results. Whereas the third factor which affects evaporation is decrease in humidity. Now, what is the term humidity? See, humidity is nothing but the amount of water vapor which is present in the atmosphere. This should be less in order to have more or higher evaporation. Humidity should be very much less. Okay, if humidity is less, you can expect the higher rates of evaporation. This is the third factor which affects the rate of evaporation. Whereas the fourth one is increase in wind speed. See, it is very much common that on a windy day your clothes get dried up very easily, because with a higher velocity of the wind, the water vapors which are present in the atmosphere, they move away. Whatever humidity is present, that is carried out by the wind, and it reduces the humidity. Okay, are you getting my point? If the velocity of wind is very much higher, the humidity or the water vapor particles are taken away by the wind, thus decreasing the humidity and helping your evaporation very much better. So, increase in wind speed or a wind blowing at a higher velocity helps for a better evaporation. So, these are the four factors which determine the rate of evaporation at any point. So, increase in surface area, increase in temperature, decrease in humidity, and increase in wind speed are the most essentials. And you can observe that evaporation also causes a cooling effect. How does evaporation causes a cooling effect? See, during hot summer, if you take the example, when you cannot tackle the scorching heat of the sun, what often people do, they go to their terrace and they sprinkle some water and they come down. How does this helps? How does the evaporation of water helps for the cooling effect is? See, once the water starts to evaporate, the liquid tries to get the energy from its surroundings. Liquid resists its evaporation. It tries to be in its own state. So what is going to happen when the liquid starts to evaporate? Liquid tries to get energy from the surrounding. Okay. This is a liquid. When this liquid starts to evaporate, okay, when this liquid starts to evaporate, this liquid tries to be in its own state, and whatever energy it is losing, that energy it tries to acquire it from its surroundings. Okay, So this causes the cooling effect of evaporation. Whatever energy is lost, that it tries to regain from its surroundings and thus help us to get a cooling effect. If you take one more example, pour some acetone on your palm, and acetone is nothing but a nail polish remover. Often girls are aware of this. Everyone, most of the girls use nail polishes and they use acetone in order to remove that nail polish. Okay, if you pour some acetone on your palm, it is most volatile in nature. It vaporizes very easily. Okay, this acetone, when it starts to vaporize, it gains certain energy from its surroundings and thus you can have a cooling effect on your palm. This is one example, and another one is earthen pots, right? Often most of the people, they love to have the water of earthen pots during hot summers, isn't it? Even in the case of these earthen pots, evaporation is going to happen. Whatever water is present, that it evaporates, and the earthen pot, it gets the energy from the surroundings and thus it gives cooling effect, and hence the water in the earthen pot is very much cool. This is one more example. Okay, and if you move on to one more topic called the clothes which you wear in summer season. So during summers we sweat more, isn't it? Sweating is very much common, and cotton cloths help us to have a cooling effect, because whatever vapors, whatever vaporization we have, that vaporization helps us to gain our cooling effect during hot summer, and also make us to feel somewhat comfortable against the scorching heat of the sun. These are the few examples of cooling effect of vaporization. And if you want to know one more interesting fact regarding this vaporization is, see, did you observe that when you take some amount of water from refrigerator or a water bottle, when you keep that water bottle undisturbed for a while, you can observe water droplets outside the water bottle. See, water is present inside the bottle. Okay, this is inside the bottle, but you can find some droplets outside the water bottle. How it is possible? See, whatever water you have kept in your water bottle, okay, whatever, I am very bad at drawing, please don't mind. Imagine this as your water bottle. Okay, if you take water in this water bottle, I am speaking about the cool water. The water vapors present in the air, whatever water vapors are present in the air, they come in contact with this water bottle, and because of the ice cold water present inside the bottle, the water vapors which come and hit, they turn into the liquid. So this is why you can find water droplets outside the water bottle. Whatever water vapors are present in the surroundings, they come and have contact with this water bottle, and these vapors, because of the ice cold water present in the water bottle, they get liquefied. Thus you will get water at the outer surface of the water bottle. So this is about the matter in our surroundings completely. So in this chapter we have seen about the different types of topics ranging from its physical properties of matter to the cooling effects of evaporization. I hope you understood this entire chapter thoroughly. If you have any doubts, you can write in the comment box and I'll reply to them. And if you find my videos most useful, please like my videos, share them and subscribe my channel. Please don't forget to press the bell icon, and if you press the bell icon, you will be notified with the recent updates in my channel AGS, only destination for learning. Me signing off, Aarifa, and let's meet with one more chapter. Thank you all.